We're going to shift our focus from equations to inequalities, and this will be a review of what you hopefully covered in middle school. Just as a reminder, these are your inequality symbols. We have less than, greater than, less than or equal to, or greater than or equal to. And one way of remembering it is the larger number is going to be where the larger opening is. And I'm sure your middle school teachers gave you a bunch of other ways of remembering which way to put that inequality symbol. But that's just one of the easiest ways that I found to remember which way to put the inequality symbol. So, like an equation, when we're using inequalities, we're comparing two expressions or two values. But instead of using an equal sign, we're going to be using an inequality symbol. So you might have a less than symbol. And that just means that what's on the left is going to be smaller than what's on the right. And again, you can see that the bigger opening is towards the right, and that's why the number on the right is bigger. You could also have less than or equal to, which is going to mean that what's on the left could be smaller or the same or equal to what's on the right. And the converse of those two symbols would be greater than or equal to. With greater than, what's on the left is going to be bigger than what's on the right, whereas with greater than or equal to, what's on the left is going to be greater than or can also be the same as what's on the right. Okay, keep in mind that with less than and greater than, it's not going to be the same. Okay, with less than, what's on the left is only going to be smaller, but cannot be the same as what's on the right. And with greater than, what's on the left is only going to be bigger, but cannot be the same as what's on the right. And these are your inequality symbols. We're going to review these a lot, so pause the video if you want to write these down somewhere in your guided notes, but we're going to write them down in just a moment. So we're going to review how to graph inequalities. Now, when we're graphing inequalities, I want you to remember what I said a moment ago. If we have less than or greater than, we can't actually be equal to or the same as what's on the right-hand side, okay? So because of that, when we're graphing this on a number line, we're always going to use an open circle when we have those less than or those greater than signs. Always use an open circle when we have those less than or greater than signs. Now, we're going to use a closed circle when we have less than or equal to or greater than or equal to signs, and that's because you can actually be equal to what's on the right-hand side, and that's why it's a closed circle. That shaded circle represents that our answer could actually be that same number, whereas if we have an open circle, it says we cannot include that number. It's either going to be smaller than or bigger than that number. I'll give you some examples in just a moment. So here we have x is less than 3. So that means x, the variable x, can be anything that's smaller than 3, but can't include 3. Now, if you think of this, there are an infinite amount of numbers that are smaller than 3. 2, 1, negative 70, negative a million, okay? So that's why we use a number line when we're graphing these. It's not just going to be one set answer most of the time. It's going to be an infinite amount of answers. Now, when we're starting this, we're going to have an open circle on 1. Now, why do we have an open, I'm sorry, not on 1, on 3. Now, why do we have an open circle on 3? Because we can't actually include 3. It's less than 3. It has to be smaller than 3, but it cannot be equal to 3. What we're going to do is, like we said before, you have an infinite amount of answers. X is going to be any number that's smaller than 3. So we're just going to shade, and I'll do it in a different color. We're going to shade everything to the left of 3. And the reason we're doing that is because those are our solutions. Our answer could be anything that is smaller than 3. If we put a negative 8 in for x, that would be true. Negative 8 is smaller than 3. If we put a negative 11 in for x, that would be true. Negative 11 is less than 3. So there's an infinite amount of solutions that we can have for x. That's an inequality. Let's do another example. Number 4. Here we have less than or equal to. So this time, we're going to have a closed or shaded circle on negative 5 because we can include 5 in this particular instance. Now, x is less than or equal to negative 5. That means it could be equal to negative 5 or it could be anything smaller than negative 5. So if we're shading this, we want the smaller numbers. Anything that's smaller than negative 5 is going to be to the left of negative 5. And if your variable is on the left-hand side, then the way you could think of it is wherever this inequality arrow, you can think of it as an arrow, is pointing, that's the side that you're going to shade. Now, that only works if your variable's on the left-hand side, but that's the way you would do this. Now, for number 5, they give us an inequality, and they're asking us to actually write it out. So if we look at this inequality, it looks like we're starting at -2. Now, are we including negative 2? No. So because we're not including -2, that means we're going to either have a less than or greater than symbol. We're not going to have less than or equal to. We're not going to have greater than or equal to. Well, if we look at this, we are going to the left. These are numbers that are all smaller than -2. So, because of that, we know our answer, therefore, must be anything smaller than -2. X has to be less than or smaller than -2. And that would be how you would go about writing an inequality given a graph. Let's do another one. Again, this is all numbers that are smaller than. This time we're starting at 0. However, if you notice, we have a closed circle this time on 0. So that means that we can include 0 itself. So instead of just being less than, it's going to be less than or equal to. And again, variable would be x. X is less than or equal to 0. It means any x could be any number that is smaller than or the same as 0. Now we're going to do one, maybe if we have time, 2 problems where we actually solve inequalities. Now, this is going to be very similar to what we've been working on already and what you worked on in middle school. You're just going to use your inverse operations and get that variable by itself. But this time, instead of an equal sign, you're going to have an inequality symbol. But I still want you to create those t-charts. You always get rid of addition or subtraction first. Do the order of operations in reverse order. So we're going to get rid of that +2 first by subtracting 2, just as if this was a regular equation. In fact, if you want to momentarily think of that as an equal sign, you can. Now, -1 minus 2 is going to be -3. And -3 is going to be less than x over 6, or x over 6 is going to be greater than -3. And then, just like if this was a regular equation, the next step is going to be to multiply both sides by 6. Get rid of that 6. And if you do that, you get your answer, which is x is greater than -18. So when you're graphing this, go ahead and write -18 here. And this would be -17, -16, -15, and -14. This would be -19 and -20. So we're starting at -18, but we're not including it because we have a greater than symbol. So we're going to have an open circle -18. Now we're looking for all the numbers that are bigger than -18, so that means we're going to go to the right. Or another way of thinking of this, because x is on the left-hand side, we could think of this as an arrow that's pointing the direction that we need to shade. So we need to shade everything to the right of -18. Now we do have some special cases that make this a little bit more confusing than equations, and I'm going to explain why this is true tomorrow in class. But the only difference, now you do all the same steps as you would with an equation when you're solving this. However, if you have to divide or multiply both sides of an inequality by a negative number, then you must flip the inequality symbol. When you multiply or divide by a negative number. And I'll give you the proof to that. I'll show you why that's true tomorrow. But anytime you multiply or divide both sides of an inequality by a negative number, you must flip the sign. Here's an example where we would have to do that. If you take a look at this, we have x plus 12 divided by -2 is less than -2. So just like an equation, we're going to want to get rid of that -2 first. And the way we would get rid of that -2, and this seems kind of jumbled, so I'm going to rewrite the problem right over here. X plus 11 over -2 is less than -2. We're going to want to multiply, put parentheses around that, multiply both sides by -2. That'll cancel these -2's, and we'd have to also multiply the right-hand side by -2. But because we multiplied both sides by -2, we are going to have to flip that inequality symbol. So instead of less than, it's going to be greater than. And then -2 times -2 is +4. Then you would just create your t-chart here. And the next step is going to be to subtract by 11. And that's going to give you x is greater than -7. So if we have -7 here, this would be -6, -5, -4, -3. This would be -8 and -9. Because it's greater than, we're going to have an open circle, and we're going to be moving to the right. We're going to be shading to the right because x could be any number that's bigger than -7, but not including -7, and that's why we have an open circle. That's it for today. We're going to do some more of these problems tomorrow. We'll talk more about inequalities, but hopefully most of you remember this from yesterday. Not yesterday, from last year and middle school years. If not, come and see me for tutoring, and I'll help you out as much as I can. All right, have a great day. See you tomorrow.